In this example, what we've got is we've got a 12 kilogram bullet. It's being fired horizontally into a 100, sorry, not 12 kilogram, 12 gram bullet, being fired into a 100 gram wooden block. The block is at rest on a horizontal surface. After the impact, the block and bullet are going to slide off together. We're given a coefficient of friction. We're asked to find what was the speed of the bullet immediately before impact. Okay, so I'm going to cover this up just a little bit, but hopefully we can see a bunch of the question. What we're asked to find is what was the speed of the bullet before impact. Okay, so this V1 over here, that's what we're looking for. We're told this wooden block is initially at rest. I'll call this object 2. It's at rest. What happens is the bullet slams into the block of wood, and this is like here, but I'm just going to draw it a little bit off to the side here just so we can see. Here's the block. The bullet slams into it, so the bullet lodges inside, and then the block and the bullet together move off with some velocity. They slide along the floor. They eventually come to rest. Keep in mind, as they slide along the floor here, there is some kind of a force of friction, right? We're told about this coefficient of kinetic friction. So as it slides along, we've got some friction. This is a completely inelastic or a perfectly inelastic collision, right? The block and the bullet stick together and move off as one object. Okay, so let's say right here, there is a V1 primed. Let's write it up here. There's a V1 primed. There's a V2 primed. I'm just going to call that V primed. Okay, so keep that in mind right here at this position. There is some kind of a V primed. I don't know what that is, but it slides along and eventually they come to rest. Anytime that there is a collision, we know momentum is conserved as long as there is no external force. Okay, so I'm going to ignore the little bit of friction in here. Over here, I'm going to keep in mind that there is friction, but for the collision that happens kind of from immediately before the collision, maybe if we say this is sort of position A where we've got block and bullet together, or block and bullet separate, and then over here, block and bullet together, call that position B. Between A and B, I'm going to assume no friction in there. This is a bit of an assumption, but I'm going to say momentum is conserved. It's a completely inelastic collision, no conservation of kinetic energy. But over here, as the block slides for a long distance, I've got to consider friction. Okay, so there's too much friction acting over here. Momentum is not conserved over here. So from B to, let's call this position C. From B to C, I can't say that, that momentum is conserved. What I can say, though, is energy is conserved. Okay, so energy at B is equal to energy at C. We've done lots of conservation of energy questions like this as well. But because there's an external force, let's slip it right in here, momentum is not equal to final momentum. Initial momentum, final momentum are not equal because of that external force. So as we do this, then we're going to have to kind of consider this in two chunks. From A to B, what happens? And then from B to C, what happens? If I look at A to B, what we've got is good old conservation of momentum. Keep in mind, this is a completely inelastic collision, so I'm going to go ahead and factor out this V primed. Okay, so it's usually, we see M1 V1 primed plus M2 V2 primed. I'm factoring out the V1 and the V2 primed because they're the same value. I'm going to get this. This is a completely inelastic collision. We know mass of the bullet, mass of the block, mass of the bullet, mass of the block. We know V2 right here is 0. Okay, so this thing, 0. Problem is, I don't know that. That's what I'm looking for, but I also don't know that. Okay, so I've got a question mark here and a question mark here. Two unknowns, I can't solve it. So let's move over here and talk about conservation of energy. From position B to position C, we've got to consider what kind of energies we have. Definitely we've got some kinetic energy right here. I'm going to call this V primed because keep in mind, this velocity is that velocity. It's also that velocity right there. Okay, this is the V primed. How fast are the bullet and the box moving right after the collision? That's this as well. We're talking about the kinetic energy there. This is total mass. It is the bullet and the block together. This is squared. So half mv squared. The height here and here are the same. So H1, H2 are the same. Again, if you think of the big, long conservation of energy equation, I'm canceling out heights. There's no elastics in this. There's no applied force other than the bullet hitting the block, but we kind of take that into account here. So immediately after the collision, there's no applied force. So there's nothing else. On the right-hand side, as the bullet and the block slide together, there's friction acting. So what we've got is some thermal energy, FFD. By the end of it, there is no momentum, no velocity, no kinetic energy. We've got no height, no springs. All we've got is this FFD over here. Now, if I can just kind of slide in a quick little free body diagram. As the bullet and the block slide together, what we've got acting here is force of gravity, normal force. This is very small. Hopefully you can zoom in a little and see this. Force of friction. That normal force and that force of gravity are the same. Remember, friction is mu Fn times d. Fn, though, is equal to Fg, which is equal to mg. What we've got is mu mgd and 1/2 v prime squared. Let's squeeze all that in here. Primed squared. Got it? This mass, as the bullet and the block slide along here, remember this mass, again, is total mass. Okay, so we know both masses. We know there's 12 grams and 100 grams. We could sub those in. We don't need to. We can cancel them out as well. Either way is fine. What we've got then is a mu value, 0.65, g, 9.8. The distance that this thing slides for, 7.5 meters. The only thing we don't know is this v primed. If we go and solve that, let's see, that is 9.77 approximately meters per second. This is not what we're looking for. This is the velocity here. I want to know the velocity over here. Okay, so we've got that. The nice thing though is, or the convenient thing maybe, is that this guy can go right in here. So now if I look at this whole thing, mass 1, 12 grams, so 0.012 V1. That whole thing is gone. This right here is the combination mass, so 112 grams, 0.112 kilograms. And this V1 then, 9.77, no squareds. Okay, so keep in mind, over here, squareds, over here, no squareds. Okay, so no squaring there. We rearrange, we can solve for this thing, 9123, and for sig digs, I guess about 91 meters per second. That's the actual answer. That is the velocity here. Stick 2 boxes around it. Initial, what was the initial speed? Yeah, it's only speed. What was the initial speed? So initial speed of the bullet.